Good evening. This is the Electric and Manual Sprayer Capstone project composed by the team members Steven Cruzado Delgado, Joshua Vélez Sotomayor, and our project mentor, Dr. Carlos Alvarado.
In the outline, we got the technology assessment at the system level, the trace study, rating and weighting, mission architecture, project interface, project plan, budget, and the three subsystems that compose our work project: system controls, requirement and assessment, structure, requirement and assessments, and hydraulic system, requirement and assessment.
Now we have the technology assessment at the system level. The first one is the Environmental Protection Agency, EPA. The second one is the United States Department of Agriculture with Technology and Development Program. And the review on pesticide sprayer technology approach in ergonomics, economics, and ecologic in agriculture field. In the trade studies, we have the three options that we can present today. The first one is going to be the backpack with the dimensions of 21 by 15 by 18 inches with a weight of 20 pounds, cost of $140, tank capacity of 2 gallons, and a flow rate of 5 liters per second with a battery of 12 volts. In the one side hand, the second option, the dimensions are a radius of 8 by 10 inches of long, weight of 17 pounds, cost of $85, tank capacity of 1 gallon, flow rate of 5 liters per second, and a battery of 12 volts. In the third option is a cart. We have that have a dimensions of 28 by 18 by 10 inches with a weight of 25 pounds, cost of $80, tank capacity of 1 gallon, a flow rate of 5 liters per second, and a battery of 12 volts. The trade study, rating and weighting, we have the MOPs on the left side, and we have the values that we assign to the three options in the trade study. And at the bottom we have the scores, having as a winner the option number 3, the cart, with a value of 7.5.
On the mission architecture for the pesticide pump, we got the system controls, the structure, and the hydraulic system.
In the project interface, we have the three subsystems and a person working as a subsystem. First of all, the person press a push button of N force in pounds that goes to the system control, and from then a power of 12 volts goes to the hydraulic systems. Then the hydraulic system at the exit goes to a flow rate of 5 liters per second. From the structure, we need a volume that the hydraulic system is gonna give. And from the system control, we need the pressure for the pressure transducer in order to the system works efficiently.
$19,200, giving us a clean earnings of $24,000.
In the first system controls, we have at the top system controls, and the tier 1, the three main components are gonna be the battery, the pressure transducer, and the main switch. In the subsystem requirements, MOPs, we have the first one, that the program must have no more of 2 inputs in order to be easy to use. In performance, batteries must last at least 480 minutes. As a subsystem requirement interface, batteries should have a 12 volts capacity, and in safety should have a pressure sensor. In the risk assessment matrix, we found the first risk in the subsystem. The first one is the cost overrun, and the approach is to mitigate as the schedule 2. Then the right software and the right hardware. The mitigation strategies for every risk are in the bottom. The first one is to make a good estimation of the hardware cost. The second one, to create a project plan for the subsystem. 3. Develop a program for the right specifications. 4. Make sure the sensor works accordingly with the program. At the right, we have the table that shows the probability of occurrence versus the impact of occurrence. In the Gantt chart, we show the next presentation dates for phase B and phase C1.
On the subsystem established as a structure, we got the tank capacities, the transport method, and the electronic compartments are the ones who affects our subsystem. As some subsystem requirements, we got the functionality, which shall have a tank capacity of 1 gallon. Now we got the performance, defined by the nozzle type must be a 45-degree configuration, the safety, where the design must weigh 20 to 20 pounds, and the agency that regule our project should be led by the EPA standards. Now, on the risk assessment matrix, we identified 5 types of risk that can damage our project, identifying them like number 1 in the cost, number 2 the choice of material, number 3 the schedule, number 4 the right design, number 5 the pressure failure. In the mitigation strategies, giving option to avoid this risk, number 1 we select an affordable tank capacity for the weight of the product. Number 2, we make a research for the best support at work. Number 3, in search of precision carefully, select an adequate space for electric component and high quality couplings. Number 4, take in consideration for simplicity and effective at work, design the body. In the right side of the slide, we got the graph that shows us the probability of occurrence versus the impact of occurrence, leaving us that the risks that we need to take more care is being the pressure failure. Now here the Gantt chart, the timeline for our capstone design, showing the due date for the different presentations.
The third subsystem is the hydraulic system. The 3 main components of the hydraulic system are: first one, the pump, the hose, and the nozzle. The system requirements: we have the shall be to function with a 12-volt capacity, must not weigh more than 2 pounds, must have a flow rate of 3 to 5 liters per second. In performance, must be able to produce a stream of 24 to 48 inches. The outlet pressure must be 40 to 100 psi, and in safety should not exceed of 10 by 10 in dimensions. The risk assessment matrix, we identify 3 risks that will affect the subsystem. The first one is the cost overrun that we have to watch. The second one is the overweight that we have to mitigate. The third one is the low pressure research and the mitigation strategies. The first one is to select the pump based on the budget plan. The second one, make the coupling selection for the right pressure. And the third one is to select the pump with the interface considerations. In the right, we have the probability of occurrence and the impact.